Hey, this is BigChungus again. We're back. My name is Eric too. I'm a protocol engineer at ChainSafe. And ChainSafe is a Web 3.0 research and development firm with over 40 friends distributed all over around the globe. And if you guys haven't heard of us before, we love blockchains. So much that we work on a lot of different blockchains. Obviously, the one that everybody's here to listen to is Filecoin. I'll be talking about some of the stuff we work on in the Filecoin ecosystem. But we also work on Ethereum. We maintain the widely used Web3.js library in the ETH1 space. And in the ETH2 space, we're building the TypeScript implementation and also doing research in light clients. We also do work with Hyperledger Besu to maintain Ethereum Classic compatibility. We also work on in the Cosmos ecosystem where we're building Ethermint, which is a Cosmos SDK blockchain with EVM capabilities. And we also work with the Polkadot ecosystem where we're building Gossamer, which is the Go implementation of the Polkadot runtime environment. So yeah, we work on many different projects in a wide array of ecosystems, which gives us a very unique advantage and unique perspective, rather, when we're working with new ecosystems and building out software and protocols there. Yeah, I'll just give a brief overview from the miner show and tell last time on our architecture. As you can see, our architecture is super simple. We have three little machines, picture down below there. We kind of represent what a quote unquote small miner would look like. We have three machines. We have what's called our storage machine, which is kind of our storage array with all of our hard drives. This machine also runs the Lotus daemon to keep up with the blockchain and runs the Lotus miner. Our other machine is what we call the seal machine or the sealer box, which runs PC1 and PC2. Lots of RAM, good CPU. And then we have our snark box, which, as the name implies, computes snarks. So that's like part of the C1 and C2 phase. And in that one, we have a couple very nice GPUs, although they're like pretty obsolete now, only like in a month or two since we bought them, which is unfortunate, but that's okay. And so, yeah, we've made pretty good progress. I guess one of our goals, we have like a couple goals with the whole BigChungus project. But one of our goals was to, kind of demonstrate and show people that, small miners can, being a small miner is actually like, feasible in the Filecoin ecosystem. In the North America region, it shows we ended up at 11th place, but we really ended up at 10th place because I think one of the miners in like 5th or 6th place or something didn't complete a sector life cycle. So I'm just going to say we ended up at 10th place. But we ended Space Race 1 with 5.5 terabytes sealed with 99% storage success rate and a 100% retrieval success rate, which is like crazy. We're very happy and proud of those numbers. And as of mainnet, so as of today, we actually just crossed the 10 terabyte mark. So now we have the minimum amount of power to start participating in consensus, which is really awesome. I think we'll start seeing our first block mined maybe in a couple of days or maybe in a week or so. So that's really exciting. I've just been looking at our logs and all that stuff nonstop throughout my workday. It's exciting, very exciting. And so, yeah, I think this just goes to show that, anybody really can participate in the Filecoin ecosystem and have a good time and mine. So like I said, that was our first goal of this whole BigChungus project. But we have other goals with this BigChungus project too, aside from just participating as a storage miner. So in other words, what I'm going to explain to you is how BigChungus can even get chunkier. And before that, I would like to introduce what we call Forest, one of our projects that we are building in the Filecoin ecosystem. So Forest is a implementation of the Filecoin protocol written in Rust. So it's very similar to what Lotus and Go Filecoin and Fuhan, or sorry, the Sorimitsu team, what they're building. But ours is in Rust, and we have a focus in safety and performance. And right now we're at the very late stages of building our verifier node, which is what most people, right now would know as, like the Lotus daemon, which, syncs the blockchain and does transaction verification and all of that good stuff. And with Forest, we plan on, building a whole Rust ecosystem around, the Filecoin stack. So we're only in our first phases, and how this kind of ties into the BigChungus, the BigChungus project is, we want to slowly replace all of the Lotus software inside of BigChungus with Forest, so we can start battle testing our implementation and making tweaks and getting it up to production, which is super exciting. We're pretty close. And we're always, we always welcome contributors. Our GitHub link is right there for Forest. So very exciting, very exciting. And our other project that we work, one of the other projects rather, that we work on in the Filecoin ecosystem is on Retrieval Markets. And so right now in the mining space, I guess the role of the miner is it's quite entangled with the retrieval side of it too, so the storage market and the retrieval market side. Right now, what we're doing is doing research and development on separating the roles of the miner into what we call a retrieval only miner. And so recently we've prototyped a retrieval market discovery mechanism using Gossip Sub to, I guess, enable that. And so what this allows BigChungus to do eventually is, to maybe even like not do any storage mining and just serve files as a retrieval only miner, or we can do both. But the power of retrieval markets is that we can separate these roles and kind of, I guess, decouple the economics, maybe even of the storage market and the retrieval market. And hopefully BigChungus will be the first retrieval only miner. But obviously, we're open sourced, so anybody can be running this. You can check out our work down here at that GitHub link on our work for retrieval markets. And as I guess as a reminder and a plug, tomorrow at I think around 1 a.m. UTC on Wednesday, David and Elizabeth are two expert engineers who wrote the retrieval markets code, will be doing a presentation on the retrieval markets. And I guess I also forgot to mention on the Forest side, tomorrow we'll be giving a talk also at 1400 UTC, where all the other implementations are also going to be presenting the work that they've been doing. So be there. It's going to be interesting. Definitely going to be a lot more details and in-depth conversations around, alternative implementations and retrieval markets. So to sum it up, like we've learned a lot through, this whole BigChungus project. And we've like one of the real, one of the main goal, I should say, of the whole BigChungus project is to understand how, how to run this kind of software, and like what kind of work goes into building this kind of or into running this kind of software from the miner side and from just the user side as well. And one of the great things about participating as a miner is that we can take the experience that we've learned from like the difficulties and the barriers in running the software, and then make our software a lot easier for miners to run. So we've lived through the whole life cycle of being a miner, staying up and upgrading software, writing metrics, tools to capture metrics and all of that. And hopefully we can incorporate that into Forest to better serve different stakeholders in the ecosystem. And so, yeah, I think that's it. That's it from me. Yeah. Feel free to hit me up on Twitter. Check out GitHub. Feel free to ping David as well. I don't think he has a Twitter, but I don't know, message him on one of his GitHub repos. Maybe he'll respond, open up an issue. So yeah, thank you. That's it for me.
Awesome, thank you. Quick question. What advice do you have for new small miners?
Yeah, so I mean, now that Filecoin has reached mainnet, so in most blockchains, the role of a miner is to provide consensus, and what that means is to participate in block production and all of that. But in the Filecoin world, miners kind of have two roles, right? If you hit the minimum consensus requirement, which is 10 terabytes right now in mainnet, then you can start mining blocks. But another way to participate as a miner is to also just be a storage miner and accept storage and retrieval deals. And I think that's like one thing that a lot of people forget. And so people are like, oh man, I have like such a way to climb now as a small miner. I have to like mine for like weeks or a month or something like that until I can make blocks and see returns. And that's not true, right? Because you can start providing deals today, or start receiving deals today to store and and to serve data. So yeah, that's one piece of advice is you don't have to mine blocks to earn rewards on Filecoin.
Yeah, that makes a ton of sense. Any other words or any other questions from people watching? The question is, what inspired you to use Rust versus Go?
We wanted to use Rust because there's a very big focus on a lot of like the security aspects of Rust that we were very attracted to. So like all the memory safety and the ease of concurrency. And I mean, like building another Go implementation, I don't think really helps many people. There's already two. So building an implementation in Rust gave us an opportunity to re-implement the VM and all the actors, which is, I think, a very important part of having like a resilient blockchain ecosystem. We've seen it a few times in other blockchains where having multiple implementations of the virtual machine and like all the other components really like save them. I guess one obvious one example that comes to mind that is like sticking in my mind since for years now is in 2016, I think around September during DevCon 2, there was a bug in, I believe, in the Go implementation of Ethereum, and that caused a fork in the network where I think they were calculating gas incorrectly. I don't really remember. It's like 4 years ago, but because they had the Rust implementation as well, they were able to keep the chain running, and they just had to make a bug fix in Geth, and then everything was all good again. So I think that's one of the big advantages of having a different implementation, and Go kind of was a natural one to write another client in. It's performant, it's memory safe, concurrency is pretty easy. Yeah, it just seemed like the obvious natural choice.
Awesome. Thank you so much.